Uh, Welcome, everyone. Thanks for coming to my talk. Today, I will be talking about how to build your first Android app. It's a guide for iOS developers, and my name is Vui Nguyen. By the way, it's so nice to see all of you. I see some familiar faces and also excited to meet some new people today. So I'm going to start by talking about our problem that we're trying to solve. So let's say you're an iOS developer and your company is asking you to build an Android app. You're like, why? And where do you start? And what things do you want to consider? So it's more than just the little syntactical differences. And what about feature parity? So let's start with a definition of feature parity. So that's just making sure that a feature works on across platforms. Doesn't necessarily mean that they're implemented the same across platforms. And as you'll see as I give this talk, that there's some things about Android that is implemented differently from iOS, even for the same feature. So what's one possible solution? Well, you all came here, so I assume you're interested in my talk, and I'm going to focus more on architecture and the process and leveraging your existing knowledge in iOS. So let's get started. So what I'm going to talk about today is I introduced the problem. I'm going to share a little bit about myself and why I'm talking about this problem. Then I'll share some goals for my talk, and I'm going to introduce the Task Tracker app in iOS. Now you're like, wait a minute, this is an Android talk. Yes, but here's the surprise, is I actually led a couple of open source projects where we built the same app, both in Android and in iOS. So part of my talk will be going over the structure of the teams that I led, the open source projects that we launched, and the project schedule itself, so you know what's involved, and you'll actually be able to see side-by-side code between Android and iOS and see how they're similar and how they're different. And the app that I'm going to talk about is a CRUD app. So for those of you that may or may not be familiar, CRUD is a create, read, update, delete. And so I'll go over the components of every CRUD app and how we implemented that. So to implement the create and read functions, I'll go over the add flow. Then to implement the update, I'll go over the edit flow. And to implement the delete function, go over the delete flow. So after I go through the code, and you'll want to stay to the very end because then I'll give the demo of the Android app so you can see how that all worked out. So hopefully that will incentivize you to stay. And then I'll wrap up with some final tips on building a standalone Android app and share some resources and share some important shout-outs to people who helped me out with this talk and the projects that I led. So a little bit about myself. Again, I'm Vui Nguyen, and I've been a software engineer for many years across many different tech stacks. I've worked as a mobile developer since 2011, cross-platform on iOS, and also learning Android. I'm a technical leader, and a little bit of news. I was the leadership fellow for a nonprofit called Women Code Mobile. Those of you that don't know, unfortunately, the Women Code organization shut down back in April, not too long ago. And I'm also a mom of a 2.5-year-old schnoodle that is a poodle and schnauzer mix. And I also like to go fishing occasionally. So first, I want to share what this talk is not about, just to kind of set some expectations. so you know what this talk will cover and what it won't cover. So it's not an analysis of native versus cross-platform, because I know some of you might be thinking, well, if you're going to build both an Android and an iOS app natively, why not just build one code base that will do both? And the short answer is, since I've been a cross-platform developer as well as a native mobile developer, I can say that no technology solution is perfect and solves all your problems, okay? So if a company decides to go with one solution versus another, there must be a reason for it. But that being the case, you know, you want to think about, this talk is really about using what you know and leveraging that to build something that might be similar but a little bit different. And similarly with generative AI, can be good for some things, but it can't build your entire app for you. You still need to rely on your logic and your knowledge of mobile development and architecture to lead development. And then you can use generative AI, other tools to kind of help you with syntax and, you know, smaller pieces of your app. And you know, this is not a beginner talk, so this assumes that you have some at least intermediate level knowledge of mobile development so you can get the most out of my talk. And you know, this isn't like, we're not going to debate what are the best XYZ design patterns and so forth, because you know, you can go down a rabbit hole for that. But what this talk is about is how to get started. Use what you already know to get started. And that's important because sometimes you get too focused on what is the best way to do this before you even start. Then you kind of get into the analysis paralysis thing and you don't begin. So, you know, progress over perfection. Get started, improve as you go. And this is really about me demonstrating the process for building a mobile app, which you can apply to any platform. So now I will introduce the Task Tracker app. As I mentioned before, this is a mobile app that I helped lead the development for, and I'll show you the demo. It is a way to keep track of tasks that you worked on and how long it takes for you to do them. So we'll start by editing an existing task. And the pickers for iOS are a little bit cumbersome, so it's going to take a little while. And you have to tap right in the middle of the button for it to work. So we've edited that task. But we decide, well, maybe we want to delete it. Or maybe not. And then we can decide, well, no, I really want to delete it. So now it's gone. But then I'm like, oh, I regret it. I really wanted that task. So let's re-add it. So this shows you the add function. And then you can update the time using the pickers. A little spoiler alert, the pickers for the Android one work a little bit faster, so you get to look forward to that later. So that is a typical CRUD operation mobile app. Okay, so now that you kind of have an idea what we're building, now we'll talk about how to build Android and iOS apps in parallel. So, bless you. So as I mentioned before, I led a couple of open source projects building the same app. So we actually, as I already said, we have an Android app that we built at the same time. So how did we do it and what lessons did we learn? So a little background. First of all, Women Code Mobile was an online technical track community that was part of Women Who Code, which is a nonprofit organization whose mission is to empower women to excel in technology careers. Due to funding challenges in today's economy, unfortunately, they just shut down back in April of this year. For these open source projects, we had project maintainer teams. So as a leadership fellow, I led these volunteers to host these events and projects. Let's see. So I created these maintainer teams based on the volunteer skills, interests, and availability to commit to the project. So that's how we started forming these teams. And for the contributors, the open source projects, they comprise of the community members of Women Who Code, as well as the volunteers. So the breakdown of the project teams were each team had 2 to 3 project maintainers. So Android, we had Gary, Ren, and Sapita. For iOS, the maintainers were Claudia and Devanshi. And we also had a project manager, Cecilia, who was project manager for both. And I was the project lead and architect. So there was a lot of preparation leading up to development itself. In October of last year, we hosted an open source contribution workshop. Then in November, we hosted an open source maintainers workshop. And the reason for this was that we wanted to start training volunteers and community members on the open source workflows and processes before we could launch. And a few of the volunteers stepped up to lead and teach those workshops, which was super helpful. Then in December, I finalized the maintainer teams. And I started leading the maintainers in discussions on what the app idea was going to be, get some app wireframes started, and figure out what our MVP project scope is going to be. So a quick definition of MVP is minimum viable product. And it's a version of a product that has just enough features to be usable according to Wikipedia. So continuing on our project schedule, after we had the workshops to train people on the different processes, we finally had a kickoff in January of this year. So we had a kickoff event for each platform over Zoom. And at the kickoff event, we introduced app wireframes to the community. We had some initial project folders set up on GitHub using the MVVM structure. And we introduced the open source process and workflow to the community. And we also established GitHub and the official Slack channel for project collaboration and communication. So a lot more going on in the January kickoff, because that was also when we had set up the project, the GitHub project boards. And we created epics from the app wireframes and then had those broken down further into smaller issues. And we also wrote up some initial GitHub issues, so we had some issues ready to go when we launched. And I want to give a huge shout out to Cecilia, our project manager, for doing all this initial project management work at the kickoff. And here are some screenshots of our Kanban-style GitHub project boards at the height of the project. And continuing on, so in addition to the, at the kickoff, we had some beginner issues written up to help some people that are new to open source, to get them more familiar with open source and contributing to our project. So thanks to Sapita, who was the Android maintainer, for writing some of those up, and Claudia for writing those up for iOS. And the work on the projects officially started at this point, and within a day or two of the kickoff events, we already had some PRs merged from contributors, so that was super successful kickoff. So now we move on to February, and we've been working on the projects for about a month now. So it's time for us to have a status event, and each platform gave their status event over Zoom, and iOS actually ended up delivering the MVP 1 month after kickoff. So they did really well. The Android project also demoed their progress. They were struggling a little bit to make MVP, but everyone celebrated the contributors' progress so far. And so actually what happened with Sapita was she took a lot of initiative with creating those beginner issues. So she only started off as a contributor, but because she was so active and because the Android project was struggling a little bit, I promoted her from a community member of Women in Code to a volunteer and as a contributor to a maintainer on the Android project. And another thing that I did was I created a couple of GitHub templates for writing issues and PRs because the feedback that we were getting was that the contributors are struggling with working with a blank slate. So I created some GitHub templates to help them get started. So now we're on to March, and this is when we wrap everything up. And lots of positive things happened up in March. Since iOS already delivered their MVP, they actually had a couple of bonus features this time to demo. One was a swipe the row to delete and also a task priority. And Android got caught up and delivered their MVP. Woo! So that was pretty exciting. Other things going on at the wrap-up event. Since the projects wrapped up, after the wrap-up event, we closed all open issues, just so we had like a clean slate after that. We had a final celebration of all the contributors, thanking them for their work. And yeah, we had 12 plus contributors combined on each platform, so a lot of community engagement. This was a pretty big deal because for Women Code Mobile, we had a lot of different events, speaker talks and so forth, but the open source projects was the most community engagement we've had out of all the things we've ever hosted. So this was a pretty big deal to have so many contributors. And then we had a meet and greet at the end after the official presentation was over. That was not recorded, and we got to hear from the contributors about their experiences with open source projects, and we had a lot of positive feedback because for some of them, they said it was their first time submitting a pull request or their first time contributing to an open source project or working as part of a team. So, we provided something very valuable to the community, so it was very positive to hear that feedback at the meet and greet. So here's some screenshots from the Android wrap-up event, and by the way, I will share these slides afterwards, so in case you want to check out the recording later. And a couple of fun screenshots from the iOS wrap-up event, which was also very successful. Okay, so now that you know how we set everything up and how it went down, so let me talk about how to build a CRUD mobile app on any platform. So first we want to start with the architecture. So we used MVVM because it's a good way to separate the UI from the business logic. And as you can see here from the project structures, they look very similar. And of course, you need the UI. For iOS, we use Swift UI. For Android, we use Jetpack Compose. For the business logic, for Android, we use Kotlin and Vue models. For iOS, we use Swift and Vue models. And this is where things diverge a little bit, gets a little bit complicated. For iOS, we use the navigation stack and navigation link. For Android, there is compose support for navigation, called a nav controller. And this gets a little bit more complicated, but what gets really interesting is when you get into persistence. So for Android, they use the room database, but they also use coroutines, which are asynchronous calls in order to access their database so it doesn't block the UI. And for iOS, we used Swift data. And things get even more complicated now when we start talking about binding data to the UI. So for Android, they use closures to capture updated state from the UI. They also use state flows to expose the database to the view model. And then the view model saves the captured state into the database through the state flow. And the view model updates the UI from the database through the state flow. And you'll see some of these code snippets when I show you side by side in a little bit. For iOS, we're a little bit spoiled because property wrappers do the data binding to the UI for us and also captures state. Swift data, like I said, kind of encapsulates a lot of things for us, and so do the property wrappers. And then next, we need the app flows. So both iOS and Android implement CRUD using these following app flows, which I will go into in a little bit more detail right now. So first, let's go over the add flow. So here's the wireframes that the maintainers put together. It was led by Ren, so it's super helpful, help the contributors get started. So the idea is you tap on the plus button. That gets you to the detail screen, and then you use the controls to fill out your task, time, and text. And then when you are done, it returns back to the list screen. And the add flow is the same for iOS. The difference here is the controls for the date and time pickers are iOS specific for these wireframes. So the first step of the add flow is to display the plus button on the list screen. We will be using the plus button to navigate to the detail screen. So on Android, we create a custom icon to display the plus button. And on iOS, we take advantage of the built-in system symbol. And then once we tap on the plus button, we navigate to the detail screen. So we take advantage of the nav controller and nav host on Android to move to the detail screen. And on iOS, we navigate to the detail screen by presenting the detail screen as a modal sheet. And here's the detail screen with just the components. As you can see so far that I'm leaving out like the component modifier, styling, logic code. So just to try to simplify things for you a little bit. There's a lot going on here, so I'm going to go through each component in more detail over the next few slides. So let's start from the top by displaying the date button. And here's the code for the date button on iOS and Android, a little bit more zoomed in. So once you select, tap on the date button, that brings up the date picker. And for Android, we have to build a custom detailed date picker dialog, whereas for iOS, we have a native Swift UI component date picker, and we can set the displayed components parameter to .date. And here on Android, date picker and date picker dialog are compose components. And date picker, as I mentioned before, is a native Swift UI component. So now once you select a date, that gets captured in a closure on Android, and then that captured state will get updated in the view model, but will not get saved to the task model yet. And here on iOS, the property wrapper at state captures the state of the date for Swift UI. So now let's move on to displaying the text field. We have a native Jetpack Compose component called outline text field, and here text field is a Swift UI component. So now we update the text field in the view model for Android, and then once again we use the state property wrapper to update the state in Swift UI for the detail screen. So now let's display the time buttons. And here, when we tap on the time buttons, we get the time pickers. And just a little bit more code there for time pickers. So you can see that time picker is a Jetpack Compose component, and date picker is a native Swift UI component. And this time you display the time by setting the displaying components to hour and minute. And so now for Android, once again, you save the state of the time selected in enclosure, and we use a state property wrapper to save the state in iOS. And then here we update the state in the view model. As I mentioned already, we update the state in iOS with the state property wrapper. And right now, everything is just kind of saved in the view model or in the screen, but we haven't saved it off to the database just yet.
Does Android have something similar to the at state, or is it Android have something similar to the state?
Oh, so the question is, does Android have anything similar to the property wrapper at state?
Like binding to the...
Right. So I found from looking through the code, the short answer is no. So they use closures to capture the state, and then they save that to the view model. So they have to actually implement two-directional binding manually, whereas the Swift property wrappers does that for you automatically. Okay. So now we are going to display the Done button. So now we're getting close to setting everything up to saving into the database. So here, Outline button is a Compose component, and Button is a Swift UI component. And when we tap on the button, now we're finally saving all the state into a new task, and we're getting prepared to save that task to the database. So now let's talk about the task model. You see that it looks similar between Android and iOS. Notice for iOS that duration is a calculated string value inside the task class, and task is tagged with the @publish property wrapper so that any changes to task auto triggers updates to the view. So Mohammed, to answer your question, this is how the two-directional binding happens via the property wrappers, whereas you don't get that automatically with Android because they don't have anything equivalent. All right, so now let's continue with saving the new task. Yes?
Sorry, why can't you why not use the computer property on Android as well for duration? Because these database models don't let you add a question.
Okay, so I don't know how to go back, or can I? Okay, so the question is, why can't we use a computed property for duration for Android? And I suppose you can, but the contributors for this project just chose to implement it a different way. So, yeah. They could have done it that way too if they wanted to. The two teams didn't really talk to each other. Okay. So here, now we're saving the new task, and the thing I want to point out with Android is that we have to make an asynchronous call called a coroutine to insert the task into the database on a background thread or view model scope, so it doesn't block the UI. Whereas we use in iOS, we insert the task into the model context, which is a Swift data model context to perform database operations. So for iOS, we're already done with adding the new task in the previous slide, so there's nothing more to show here. But for Android, as I said, there's more. So in the view model, we insert the task into the repository, which is an instance of the room database. And as mentioned before, this is done as an asynchronous operation. And then inserting into the repository calls up the database access object, which then inserts the task object into the database for us. So now that we're done adding the new task, we can navigate back to the list screen. And once again, we use the navigation controller on Android to navigate back to the list. And on iOS, we use this native dismiss function to close the detail screen and to display the list screen underneath. So now that we're back to the list screen, we need to display all the tasks, including the one that was just added. So we do that by getting all the tasks from the database, including the one that was just added, and we prepare to display them as individual rows of tasks on the list screen. And on Android, they create a custom view called task card to display a single row for a task. And on iOS, the contributors built a custom Swift UI view that they call activity item view, again, to do the same thing, to display a single row for a task. So that was a lot. That was actually the hardest flow, so everything else here would be a little bit easier. So now on to the edit flow. So this one I'm going to focus more on what happens when the user clicks on that cancel button. I'm not going to go through all the database stuff in great detail, except when it relates to saving an edited task. So this should be familiar. So we first start with displaying the list screen by grabbing all the lists from the database and displaying them as individual rows. And then this time we need to tap on a row to navigate to the detail screen. So we use a navigation controller to do that on Android, and on iOS we use navigation link. So now that we're on the detail screen, we want to display the cancel button. This is how we do that. And we're done with the code to display the cancel button on iOS. So here's a little bit more code for Android. You'll notice there's actually a lot more code involved to do similar things on Android versus iOS. Okay, so now pressing the cancel button will display this cancel confirmation dialog. And the cancel confirmation dialog lets you know that you have unsaved data and are you sure you want to close without saving. So for Android, they implemented a custom confirmation dialog, and on iOS, we implement a custom pop-up view. And when we tap on, let's say we start by tapping the OK button, what that will do is it will dismiss the confirmation dialog and return us to the list screen. And now let's assume we tap on the cancel button, and the result is we will dismiss the confirmation dialog and stay on the details screen. And the side-by-side comparison looks a little bit confusing since the two groups implemented this a little bit differently, but behaves the same way. So, and let's say we've dismissed the cancel confirmation dialog, and now we're back at the detail screen. So now we want to tap on the Done button to save the edited task. And once again, we make an asynchronous call to update the task in the database on a background thread or view model scope. And we update, for iOS, we update the task in our model context. And then we navigate back to the list. And as I mentioned before, we use a navigation controller on Android to navigate us back, and we use the native dismiss function to close the detail screen on iOS. And then we do what we've done before to retrieve all the tasks from the database, including the one that was updated, and then display them as rows on the list screen. And this is how we do it for individual rows. So that was the edit flow. The last flow is our delete flow. And here I'm going to focus on what happens when the user taps on the trash can to delete. So we do the same thing as we did before with displaying the list of tasks. And once again, when we tap on a row in the list screen, that navigates us to the detail screen. And so I'm going to mostly focus on the delete button, as I said, and what happens when you delete a task. So as always, there's a little more code involved with displaying the delete button for Android. So now when we tap on the delete button, that brings up the delete confirmation dialog. And here the dialog asks if you're sure you want to delete this entry. And here for Android, the state of the show delete confirmation pop-up is captured in a closure. And for iOS, it's captured in an @binding property for iOS. So if we tap on the OK button here, we will dismiss the dialog, delete the task, and return the list screen. So we'll go over those steps in more detail in the next couple of slides. So now we're going to delete the task from the database. Same as always with Android, we do that in the view model scope, and we delete the task in the model context for iOS. And then we're going to, after we delete it, we're going to get ready to return to the list screen. And we retrieve the task from the database. This time it will not have our deleted task. And as a reminder, these are custom views. Task card for Android and activity item view for iOS were built by the contributors. Okay, so now that I've shown you the demo for the iOS Task Tracker app and the code side by side, I'm sure you're excited to see like the final result. So here it is. This is how the Android app turned out. So it's kind of similar as the last demo. Let's go ahead and edit an existing task. And as you can see, the pickers are actually a little bit nicer. They work a little bit faster on Android. And then we decide, well, that's great, so we edit it, but what if we want to delete it? So, but let's change our mind, let's not delete it. Or maybe we really do want to delete it. And now it's gone. But now we have some regret, so we want to re-add it. So we're going to do that. This demo is just a little bit faster because the pickers are a little bit faster on Android. So now you see we have feature parity, and they work the same for Android and iOS. So let's real quick go over putting all this together, some tips for building standalone Android apps. I would recommend using Kickstarter tutorials just to learn some basic things. It's like setting up your development environment, running a Hello World app in the simulator. I would recommend using sample applications as a starting point for what you're building. That's really great for architecture, infrastructure, that sort of thing. And I would focus on learning the why, the architecture, the theory, the process for mobile development. And for syntax help and deeper dives, this is actually a good place to look up APIs and use generative AI for helping you with syntax. And as a bonus, if you want to do some practice in real life, I would recommend maybe finding some open source, speaking of which, projects and starting with the beginner issues. So here's some resources. As I mentioned before, Women Code closed down, so they took down our GitHub repo, but I fortunately had the presence of mind to create a fork. So you can check out those branches if you like to use that as a reference maybe for your projects. And here's some links if you want to get a deeper dive into learning Android. And I want to make time for doing a couple of shout outs. So here's the wonderful team behind the Android Group project, as well as the contributors for whom all this was possible. And here's also the wonderful iOS project team, including the maintainers and contributors. And I want to thank a couple of people who helped me with my talk. As I mentioned, Sapita was the one that I promoted to a maintainer, so she helped me review my talk on the Android side of things. And Itunu, who is also a volunteer and an active volunteer and a top contributor on the iOS project, helped review my talk on the iOS side of things. So we covered a lot today. This was all the things that we covered. And that's my talk. Thank you so much.
We don't have time for questions.
Oh.
Switch over to the next speaker.
All right, well, thank you. If any of you have more questions later, you can write them in my talk channel or come talk to me. Thank you so much.